Okay, you need a pen, something to write with, and you need your 3 origami papers. So you are doing this individually, and you will give this to the substitute with your name on it at the end of the class. Okay, so what I want you to do is go to your pink paper. The pink and the yellow are going to represent both sides of the DNA double helix. So that twisted ladder that curves around, this is going to be the sides of it, yellow and pink. So it's made of alternating sugars and phosphates. That sugar is deoxyribose. So instead of putting D, because it looks like P, I'm going to put S for sugar inside every single one of these pentagons. We made these with the molecular model kits the other day. So I'm just putting S for sugar in here. And every single pentagon. There we go. I'm going to do the exact same thing over here on my yellow sheet. So now I have my sugar, phosphate, sugar, phosphate, sugar, phosphate backbone. Okay, the blue is going to be the nitrogen-rich bases. They just have nitrogen in them. That's why they're called nitrogen-rich. Okay, so you have all of these papers, and you can see you have the AT bonds, and you have the CG bonds. Now the difference between the two is how many hydrogen bonds are going to form between each. AT bonds only have 2 sets of hydrogen bonds. So these are gonna be like the rungs of the ladder, like this. And I'm gonna show you what connects them in the middle, a very weak hydrogen bond. So we'll represent it by dotted lines. Here's hydrogen bond number 1, here's hydrogen bond number 2. So go through each of these AT bonds and put in your 2 hydrogen bonds between. This is what's going to hold the 2 sides of the ladder together. It's a very weak bond. So go ahead and nitrogen to hydrogen, oxygen to hydrogen at the top. Okay, for the CG bonds, what you're going to do is they're going to be a stronger bond. They're going to be held together by 3 hydrogen bonds. So I'm going to go up here to the top, NH2 to O, nitrogen to hydrogen here, oxygen to hydrogen. Remember, whenever hydrogen is 1/2 of the relationship in the chemical bond, it's always called a hydrogen bond. It's very weak. But because the way they're oriented, there's 3 that are possible instead of just 2. So go through each of the CG bonds and put your hydrogen bonds in as well. Okay, so once you've done this, get your glue stick, watch Mrs. Perkins' video on DNA origami, and just continue with the formative. Thank you.